This is the PACE6000 Precision Pressure Controller Calibrator, where either a single pressure control module can be fitted or two pressure modules. These modules can easily be installed and removed for recalibration or range changes, enabling future expansion as business needs change. The measurement precision of the modules is 0.005% of reading plus 0.05% of full scale with a control stability of 10 ppm. Using the intuitive menu, the pressure range or auto range can be selected from the choice of up to two installed control modules. If two control modules are installed, the user can also determine if the PACE6000 is to be used in a single channel mode or in a dual channel mode. The dual channel mode will enable an operator to control two pressure outputs simultaneously. Once the range and either single or dual channel mode have been selected, the operator should select the pressure units to be displayed in line with the units of the device under test. The PACE6000 is designed with an easy-to-use task-driven menu. To calibrate a pressure gauge, select the basic task, put the pace into control mode, enter the set point. Once the pace has achieved the set point, the display will turn green. The nudge button can then be used to line the gauge pointer with the dial marking before noting the pressure applied. Enter the set point to the next cardinal point. Repeat until the calibration is complete. An alternative to entering the set point at every cardinal point is to use the divide task. A full-scale range of 2.5 bar is entered. The start point is 0 and a number of cardinal points 6. After the pace has been put into control mode, the pressure can be stepped through the cardinal points by simply pressing the nudge buttons. The preset task works like the divider task, but enables the user to define the pressure set points, meaning that a non-linear calibration can be performed. The first preset is 0. We set preset 2 to 0.5 bar. Preset 3 is 1. After the pace has been put into control mode, the pressure can be stepped through the cardinal points by simply pressing the nudge buttons. To test for leaks in the test system, or to ensure there are no leaks in a device under test that has been dismantled and reassembled, the PACE6000 has an optional leak test task. Both a negative test pressure and a positive test pressure, along with the control dwell, can be entered. The leak test time, called measure dwell, is entered in hours, minutes and seconds. Once the test has been started, the PACE will evacuate the system to test pressure 1. The PACE will measure any pressure change during the leak test period, called measure dwell. The leak rate is calculated and displayed. The PACE now repeats the leak test with a positive test pressure 2 before a final display shows the start-end pressures along with the leak rate of both tests. For the calibration of pressure switches, the PACE has an optional dedicated switch test task. From the menu, all start, test and end parameters can be entered. In the test setup, 0.6 is applied as set point 1, which is below the actuation point of the pressure switch under test. Set point 2 is 1.7 bar, which is a higher pressure than the actuation point. Once the test is started, the PACE will achieve the 0.6 start point. The pressure is slowly increased until the contacts change at 1.5 as indicated at the bottom of the screen. The pressure is then reduced until the contact change is captured at 0.81. The test is now repeated with the contact change points being captured. The maximum, minimum and average switching points of both tests are calculated and displayed. For any customers who have an automated test, we have a dedicated test program task. A new test program can easily be created by first of all naming a program. Commands can be inserted into the program. As a simple example, we will set this test program to enter control mode. Control to a set point of 0.5 bar, dwell for 5 seconds. Control to a set point of 1 bar. Ending the program and saving the file. We run the program by pressing the green traffic light. The PACE will now follow the program that can be as short or as long as defined. For rupture point testing, the PACE has an optional burst test task. From the menu, the start set point pressure is set. The end set point of 1.2 bar is entered, which is higher than the expected burst. The slew rate can be changed if required. The burst test is started by pressing the green traffic light. An increasing pressure is applied until the pressure is released by the burst disc rupturing. The PACE captures and displays the burst point of the device. In the aerospace market, precision and reliability are paramount. The PACE6000 has an optional dedicated aeronautical task to enable the calibration of avionic equipment to be performed. On the left side of the display, we can simulate altitude, and simultaneously on the right side of the display, we can simulate airspeed at altitude. The rate of climb can be entered. The rate of calibrated airspeed can also be entered. A set point to simulate an altitude of 36,000 feet is entered. A set point to simulate an airspeed of 400 knots is entered. The PACE is now simulating a true airspeed relative to the altitude at the predefined rate of climb and rate of calibrated airspeed. When the go to ground button is touched, the altitude will decrease proportional to the airspeed at a controlled rate. The PACE6000 is part of a collective modular family of precision indicators or controller calibrators. For more information or a live demonstration on any of the PACE series, please contact your local GE representative. GE Imagination at Work.